Hi, and welcome to our last video on factoring, which is special techniques. And now we've really already talked about all of these techniques before. We've just gone from multiplication of two binomials to a trinomial, and now we're going in the opposite direction from trinomials to two factored out binomials, okay? And when we went in the other direction, we talked about perfect square trinomial. We're going to talk about it again. And then we also talked about difference of two squares, and we're going to talk about that again. And then we're going to talk about the cubes as well, but we'll get to that a little bit later. First things first, I need to make sure that we talk about what a perfect square is. And when I'm looking at perfect squares, I'm really looking at all these highlighted yellow numbers. All of these numbers are basically the square root of, so like 1 squared is 1, 2 squared is 4, so square root of 4 is 2, basically. 3 squared 9, 4 squared 16, and I can keep going, right? So that's really what we're looking for, okay? We really need to make sure we understand that. Now, if I'm taking a look at my examples here, I'm really interested in these two numbers, okay? Because 9 is a perfect square. That's 3 squared, okay? And x squared is always a perfect square, okay? Because x times x is always x squared. So 3x is what I'm going to call my a value. And my b value is going to be the second number, just 4 is the perfect square. So really we're almost like taking the square root of 4, which is 2. So b is going to end up being 2. All right, so I need my A and I need my B, and then I just am putting it essentially in these formats right here. And this example kind of goes through the whole thing. Basically, here's my A, here's my B, and this is A and this is B, and I'm multiplying those together and then I'm multiplying it by 2, which is what 12x is, right? So I'm able to put it into the A plus B squared format. And keep in mind, notice that it's because both of these are positive. In the next example I have here, I have a positive and a negative. So if I'm looking at kind of like my rules from the beginning, it's going to be the second one where I have a negative inside my squared, my parentheses squared. Okay, so I'm basically going to be doing a minus b squared. That's kind of where I want to put it into. So 81, really that's 9 times 9, or 9 squared. So my a is going to be 9, and then y squared is always just going to be y. So that's my a value. And then my b value is going to be the square root of 16, which is 4. So guess what? 9y minus 4 squared is my answer. That's my factored form because it's a perfect square trinomial. I can keep going. Okay, I take a look at my last two. Well, 36 is 6 times 6, so a is going to be 6, and then x squared is always going to be x. B is 49, so 7 times 7 is 49, so it's 7, and then I have a y squared, so just y. Both of these are positive, so I'm going to be putting into the parentheses a plus b quantity squared. So I'm going to put it into my format. I have 6x, that's my a, plus my b, which is 7y squared. That's it, guys. That's really that simple. Okay, I'm going to, I don't feel like we need to do all the rest of these. Let's just do maybe this next one over here, this last one, before we talk about difference of squares. So I have here first term and last term, but notice I have actually y's in all of these. So I can actually factor a y out first, and then we have 36x squared minus 48x, and then plus 16. Okay, that looks a whole lot more familiar than what we were doing before. So I'm going to take a look at my first and my last term, and I notice that my 36 is really 6 times 6, so that's 6, and then I have an x squared, so x, so a is 6x, b is going to be 4. So 4 times 4. Okay. So I'm going to have y, because we need to make sure we hold on to that. And I'm going to have 6x, and then I have 4, and that's going to be squared. But I need to figure out what sign is going to go in here. Are they both positive, or one positive, one negative? And it's my second one's positive, my first one's negative, so it's going to end up being negative. Could we FOIL this all out to check? You absolutely could. That's the beauty of these. You can check to make sure that you're doing it right. All right, difference of two squares. And again, the beauty of these is that we are creating patterns so that we are able to basically skip quite a few steps of factoring. Okay, so again, you are looking for two terms that are perfect squares with no middle term. Okay, that's it. All right, and then we're essentially going to factor it into two parentheses, 1a, and the second one's going to be b, and 1 plus 1 minus. That's it. That's really all we're doing. Okay, so basically we're looking at these first two and finding out the square roots. Those are going to be our a's and our b's. Okay, not a big deal. Keep in mind, this is always like a 1 if we don't have a number. So my a in this case is going to be 1x. My b, well, 2 times 2 is 4, so 2 is going to be my b. So if we follow this example, this is my a, this is my b, this is my a, this is my b, positive, negative. That's where those numbers are coming from, and then they double checked it. So again, I have a procedure here. I don't feel like we need to follow it necessarily. Here, just using our words, but we are going to go through this exact same procedure when we're doing the problems. So for example, I have 64y squared minus 1. Well, 64 is 8 times 8, so 8, and y squared is always y. And then 1 is 1 times 1, so our b is going to be 1. So this is going to factor out to b, and I have to have two sets of parentheses to have two terms separated by a negative. My a value, which is 8y, so my first terms are 8y, and then my b value is always 1. One's plus, one's minus. That's it. That's all, folks. 121. Okay, we didn't talk about this one, but it's going to be 11. So a is going to be 11, and then we have x squared, so x. B, 49, which is 7 times 7, y. So when we factor, we're going to have 11x as my first term, 7y as second term for both sets of parentheses. 1 positive, 1 negative. That's it. Okay, now for this next one, I'm not going to do the last one. Actually, we should do them. Never mind. I changed my mind. So a here is 10. B here is h. So we factor it. It should be 10 plus h. 10 minus h. Doesn't matter where, if it's in the first term or in the second term, our variable, as long as we have it there. Okay. All right, last one here. Now these are raised to the 4th power, which means to say I'm going to have x squared, because that's the square root of x to the 4th, and y squared, x squared, y squared. One's positive, one's negative. Now here's the thing. This second set of parentheses, I have another difference of two squares. So we're going to keep this first one, x squared, y squared, with a plus. But this next one is actually, we're going to break it up even further, because the square root of x squared is x. Square root of y squared is y. One's plus, one's minus. And now we have completely factored this out. Okay, and I think I'm going to call it a day there. Now, last set here, and I'm just going to talk through and show you one example. I'm not going to show you multiple. I'll show you the positive version and the negative version. Okay, but that's it. I have more than what I need. We'll make it a short video. So these are kind of the patterns that we're following again. Okay, notice that when we have a plus, the binomial parentheses is going to be a plus, but we're going to have a negative in the trinomial parentheses. And when we have a negative in between, we're going to have a negative in the binomial parentheses, but they're all positive in the trinomial. So again, we're taking almost like the cube root here. So for this, it's going to be, so your A is going to be X, and your B is almost going to be like the cubed root of 64. Basically, how many times do I have to multiply by a number, or I multiply a number 3 times to get 64, and that number is going to end up being 4 here. Okay, because 4 times 4, and then times 4. Okay, so now let's put it into our equations. So I'm going to have A plus B, so X plus 4, and then we're going to have A squared, so X squared, minus AB, so 4X, and then plus 4 squared, which is 16. Okay? So that would be that answer. Okay, now the next one here, again, our A is going to be X, our B is going to be 10. Okay, so we're going to have X minus 10, and then we're going to have X squared plus 10X plus 100. Okay, and I'm just following the patterns for all of these. But that's as far as I really wanted to go. I do have a few more examples here. If you want to practice, you absolutely can. What I really wanted to make sure I talked about was this last little kind of graphic here, which is giving you an idea of what kind of the different strategies for factoring polynomials. The first one, obviously, you always want to try and factor out a greatest common factor. That's like the first thing that you should probably be able or try to do. Okay, now if you have binomials, meaning to say 2 terms, here are the things that you want to look for. You want to look for difference of 2 squares. Do you have sum of squares? And the sum of squares, you cannot factor it. So basically, if I have x squared plus 16, those are sum of squares. You cannot factor that. That's as far as you can go. Sum of cubes, which is what we just did, and difference of cubes, which is what we just did again. Okay, so that's kind of like the first type of problem that you could have. You could have trinomials as well. All right, so for trinomials, you could do just straight up factoring, or you could have perfect square trinomials, okay, where we talked about how to do it in this video, okay? And then the last one is the more than 3 terms, and that was in the previous video where we did factoring by grouping, okay, my personal favorite. All right, so here are the different ways or the different tools we have for factoring in general, and the different ones we have specifically for binomials, specifically for trinomials, and for more than 3 terms. Okay, so I would highlight, take a screenshot, write it down, just so you can use this as kind of a way to check yourself and a way to practice all of these different factorings that we've done. All right, that's it for this video, and I will see you next time.